All right, now we're ready to do the application questions. So I just want to give you guys some hints on how to get started. So the first one says to show that the equation for voltage across the resistor is given by this equation. And the hint says to begin with the equation given in the introduction, use Ohm's law and the definition of current. So I go back to the first page and I want to look at the charging capacitor. So that's not this one, it's the second one. So I start by writing that. So Q at any given time is going to be equal to Q max times 1 minus e to the negative t divided by tau. And so the definition of current is the derivative of charge. So it's going to be dq dt. So what I need to do is plug in this equation and take the derivative of it, and that will give me an expression for I as a function of t. Then I can use Ohm's law, which tells me that V of t is going to be equal to I of t times R. So the steps that you follow are you start by writing this guy out, take the derivative. I recommend distribute Q max in the beginning so that you don't lose track of it. And so we would write this as Q max minus Q max e to the negative t over tau. Now you can take a derivative, and so take the derivative of Q max, which is a constant maximum charge, and then I take the derivative of this expression. Fortunately for us, derivatives of the exponential, that's one of the easiest derivatives around, right? So I get this, I take my result, I plug it into this expression, and then I take the result from this expression, and I plug it in there. All right, so you should be set for problem 5. And then question 6 asks if the charge ever actually reaches 0, and they want you to give a mathematical justification. So for that one, you're going to look at the first equation, which is this guy. This is the discharging capacitor, which says it's going to be Q equals some initial value e to the negative t over tau. And so what we want to know is, can this Q of t ever equal 0? And so you can look at this and make the mathematical justification and just explain your answer as to, can it reach 0, and if not, why not? If so, explain it.